let's look at this a little closer. Consider this simulation. Okay, I'm going to pull it up. Here we are. What we have here is we have two balls, a red and a blue, and we are using a simulation so we can observe how do they move. Okay, let's play it first. You notice there, this is very similar to the video that we watch in another recording. The red one is allowed to move only vertically. The blue one can move both horizontally and vertically. The blue one was given an initial velocity along the horizontal, while the red one was given no horizontal initial velocity. For the vertical, both of them have an initial velocity of 0. If you pay attention to this, you notice that the motion along the horizontal spacing between the horizontal spacing between two successive positions looks about the same. We can see it closer in a little bit. The vertical motion looks like it is identical. Okay, let's look at this a little bit more closely. That's the blue ball, and we are breaking both of its horizontal and vertical motions. See, the vertical motion is an accelerated motion between two time intervals. The displacement here is tiny, then a bigger displacement, and a bigger displacement, and a bigger displacement, and so on. Now for the horizontal, look at the spacing. This spacing is very much the same as this, the same as this, and the same as this. By the way, note that the simulation allows you to measure this, so you can put the cursor over this and read the coordinates, for example, 4.0 or about 4 here, and 0 for the y, and about, I'm not going to do it precisely, but about 6 here, 0 for the y. So this should be about 8 and 0 for the y, and so on. So it's the same displacement. However, for the vertical displacement, we see it's increasing all the time. Now, if we look at everything together, okay, you notice here, the vertical displacement of the blue ball is identical to the vertical displacement of the red ball. Essentially, re-emphasizing that the vertical motion and the horizontal motion behave independently. Now, we explore this a different way. Instead of letting things fall, we are going to impart initial velocities to both balls in this case, but for the red ball, we are going to impart a vertical velocity. For the blue ball, the initial velocity is going to have both a vertical and a horizontal component. The difference is, though, the important thing here is that the vertical component of the initial velocity that we impart to the blue ball is the same as the initial velocity of the red ball. Now, what this will result into, the same thing as we have discussed before. The vertical motion of the red ball is identical to the vertical motion of the blue ball. The horizontal motion of the blue ball is equally spaced as we expect, since we don't have an acceleration along the horizontal, since we don't have any forces along the horizontal. Remember, the only force acting on our mass in this particular case is the gravitational force, and the gravitational force along the vertical, so it results on this, in this.